The final video of transformations. This one is going to be covering dilations. And dilations are a little bit different than the other three that we've covered so far this year because for the first time, shapes are going to get bigger or smaller. So we are no longer looking at congruent shapes. We're now looking at similar shapes. And for the first time, that means that we're going to have some of the rules are going to be slightly different than what we've been working with so far in this unit. So let's go through that vocabulary one last time. The preimage is the image that you start with the image being the shape that you end with after the transformation. So far in this unit, everything has been congruent. It's been the same shape and the same size with the preimage and the image, but now with dilations for the first time, shapes are going to be getting different sizes, but by definition, the shape itself should not change. So if I start with a right triangle, I need to keep a right triangle at the end of the process. So when we think about real-world dilations, I just have a picture of some random Joe I got off the internet. If we needed to make his picture bigger, you know, a lot of programs have this thing where we pull and we can enlarge the figure. If we need to make it smaller, we can do that as well. But I noticed that as I make this shape bigger or smaller, the shape does not change, only the size does. So if I pulled at one of these corners instead, it changes the shape of what we're looking at. And so that is not a dilation. Also, if I pulled it in this direction here, that is also not a dilation. So in order to be a dilation, the shape must stay the same, but the size will change. So when we talk about an actual triangle here, and we want to dilate it with a scale factor of 3, it's actually a scale factor of 1 centimeter equals 3 centimeters like we've done in our projects before, which means that we are going to be getting bigger than what we started with, which means our image will be bigger than our pre-image. So this shape is going to enlarge. So the way that I do this problem is I always think about, once again, the origin. And I want to think about each point in relation to that origin. So D is 1, 2, 3 units away from the origin. In order to make a scale factor of 3 means that it needs to be 3 times bigger, which D prime must be 9 units away from the origin in order to match. E over here is back 1 and up 1. So 3 times bigger would be back 3 and up 3 for E prime. F is over 1 and up 2. So F prime has to be over 3 and up 6. 1, 2, 3, 4, 5, 6. So I took each individual coordinate and I increased it by a scale factor of 3. And now I connect each of my individual points. And it's usually pretty easy to tell just from the eye test if the shape changed at all. I look at EFD is the same as E prime, F prime, D prime. Therefore, the shape stayed the same, but the size changed with a scale factor of 3. So we are done. If we are looking at a shape with a scale factor of 1/3, that actually means 1 centimeter is equal to 1/3 of a centimeter, or 1 unit is equal to 1/3 of a unit, which means we are reducing, or we're doing what's called a reduction. So we should get smaller. So if we look at point S, which is over 3 and up 3, would be over 1 and up 1, because I take 1/3 of each individual measurement. So then T is over 3 down 6. So that means that it should be over 1 and down 2 by taking each of those numbers and dividing by 3. R is back 9 and up 3, so it should be back 3 and up 1. It's also a little bit easier to tell on these last points because R has to be directly left of S. So I know that R has to be on this line here. And then U has to be a direct 90-degree angle between S and T, which means U has to be right here. So I have now done a reduction of a third, and our shape stayed the same, but our size changed, so we are done. As long as you remember to focus on the origin, a lot of times these scale factor problems turn into simple multiplication or division just because we are reducing or enlarging. So for this first round, we actually have 3 questions here. And what I like to do when I have too many questions is I like to cover one up, so I'm only focusing on one at a time. So the first question is, what scale factor was used to turn the black polygon into the purple polygon? So I went from a small shape to a larger shape. So this next question asks, was this an enlargement or a reduction? Well, because we got bigger, we are having an enlargement. If we are getting smaller, we would be making a reduction. So now, in order to figure it out, there are a bunch of different ways to look at this problem. But what I like to do is I like to look at specific side lengths. And you only have to look at corresponding side lengths for each shape one time. So I noticed that side RU should match up to R prime U prime. So this should tell us what the scale factor is. So RU is 2 units long. RU or R prime U prime is 1, 2, 3, 4, 5, 6, 7, 8 units long, which tells us that our scale factor has to take some number from 2 to 8. Therefore, the scale factor should be 1 unit equals 4 units. Now you could write this as 2 units equals 8 units, but as we talked about with our last few projects, most people don't write numbers that way. So the scale factor would make more sense to say 1 to 4. IXL might just be simply looking for the number 4. So be a little careful with that. Then the question is, if the measure of angle S is 70 degrees, what does the measure of angle T prime equal to? So if we see measure of, that means we're looking for a number. So angle S right here is 70 degrees. Now by rule, that means that S prime right here has to also be equal to 70 degrees. That if these are corresponding angles, they must be equal to each other. So then that means S prime and U prime have to be the same, so this would have to be 70. So then I'm solving for angle T. There are 2 ways to solve this. If I remember that these lines are parallel to each other, that means S prime and T prime have to add to 180. Or I could do 360, because that's the full polygon. I could subtract 70 again, divide by 2 to get my answer. Either way, the measure of angle T prime has to be equal to 110 degrees. Now, what this actually means is that the measure of angle T on this shape over here has to also be equal to 110 degrees. That if you solve for one shape, as long as it is a true dilation, you're actually solving for the other shape at the exact same time. So if you have any questions, please let me know.